All right, Math 1, we are going to start no, not quite the last section, but we're getting close to the end of Chapter 3. So we are starting Section 3.6, which is dealing with slopes of parallel lines and perpendicular lines. All right, so I'm on page 212 if you want to go ahead and open your book. All right, everybody knows what parallel lines are. They're two lines that do not intersect, and when you get into Math 2 next year, we'll know that they have to be coplanar, but that's next year. Perpendicular lines, what perpendicular lines are, they are two lines that intersect at exactly 90-degree angles. That's what perpendicular means. It creates 90-degree angles. So whenever you see that, you should picture something like this in your head where you have four right angles wherever they intersect. All right. This is kind of a unique thing. So what you're going to be doing is making equations of lines, given some information. Now, you should know from the previous chapters that what you really need in order to make an equation of the line, you always need your slope. Okay, and you also need some kind of a point in order to find what you need. Sometimes that point is in the form, just a random x and y. The other time it might be in the y-intercept, which is also known as our b if we do y equals mx plus b. So you always need your slope, whether you're using point slope form or slope intercept form, and you either need a point or your y-intercept. All right, so let's go through and figure out what all this means. All right, here we're going to talk about slopes of parallel lines, and it says non-vertical lines are parallel if they have the same slope but different y-intercept. So same slope, different y-intercepts. Okay, the reason why two lines do not intersect is because their rising and running rate are exactly identical. It's kind of like two runners, running the race at the same pace. They're never going to intersect, or no one will win the race because they're running at the same pace. So if I take a look here, this is y equals mx plus b. And if I asked you for the slope, you would tell me 1/2. Here's another one, y equals mx plus b. If I asked you the slope, you would say 1/2. Since their slopes are the same, when you go to graph them, they should be parallel. Okay. All right, so let's go through and just do some examples here. Each example might be just a little bit different depending on the kind of information they're giving you. So here it's asking you, it says a line passes through this point. So I know this point has to work in the x and the y spot, but it's parallel to this equation. So the question is, what is the equation that represents that line? So I know I have a point, which is -3, -1, and I know it's parallel to this. Well, how is that helpful? Well, any line that is parallel to this line has to have its same slope. So you would look at this and say, well, what is the slope of this line? Well, since it's in the form of y equals mx plus b, your m is 2. So I'm going to go borrow that slope, which is 2. Ignore this now. I don't care about it any longer. And I'm given a point and a slope. So the question wants us to put it into slope-intercept form. So in order to put this into slope-intercept form, there's a couple of ways to do it, but I think we'll go to the way we did it before. Slope-intercept is your mx plus b. We know our m is 2. We just don't know our b, but I am given an x and a y, so I'm going to take the -1, put it in place of y, -3 here, which makes it -6, plus b, add my 6 over, so -1 plus 6 is 5. So b is equal to 5. So the equation would be y equals 2x plus 5. This line is parallel to this one, but it goes through this point, whereas the other one did not. All right, so same idea. You're going to be writing the equation in slope-intercept form, y equals mx plus b, through this given point, parallel to this one. So all you're going to do is use this point, borrow this slope. So the slope is -3 over 2. Then I ignore the rest of this. So I'm going to say y equals -3 over 2x plus b. I'm going to put this in for the y, and I'm going to take 2, put it right here. Well, -3 halves times 2 is -3. All right, add my 3 over, gives me b to equal 2. So finished equation, I guess I'll write that here, b is 2. Y equals -3 over 2x plus 2. Okay, so these two should have the same slope. The only difference is they have different y-intercepts because this one has to go through that point. All right, once you pause the video, try this one on your own and see how you do. All right, since the b was 0, you don't need to write plus 0. You're not wrong if you do, but you don't need to. All right, this is the exact same concept is going to happen down here. Well, I can't say exact because it's not exact, but it's very similar. The perpendicular lines right here, they explain how they form right angles, which is what I said earlier. But on this case, if you have perpendicular lines, right here is what it says. The product, which is when you multiply, of their slopes is -1. So what I like to say is that they are opposites and they are reciprocals. Now, what a reciprocal is, you learned that probably down in grade school. It's when you have a fraction and it is like flipped over. So for an example, if you take 2/3, its reciprocal would be 3/2. Now, the fancy thing about reciprocals are when you multiply them, you always get a 1. So if I multiplied across, I would get 6/6. And 6/6 always gives me, you know, and same thing always makes a 1. So when you multiply reciprocals together, they should always get a 1. So their slopes should be opposite reciprocal. Now the word opposite means if one is a positive, the other one has to be a negative. All right, so end result is the slopes of the two lines need to be opposite reciprocals. So what that says is when I multiply their slopes together, every time I had better get a -1. If I don't, then you're not using the right slope. All right, so here they're giving you a half. Well, the reciprocal of 1/2 is 2/1. So that's the number 2, and one's a negative, one's a positive. So these would be parallel or perpendicular. All right, so let's go through some examples with that. Same type of idea. So here they talk about that, I guess, on the top of page 214, your opposite reciprocals. All right, so they practice that a little bit. All right, so what we're going to do here is just decide, are these lines parallel, perpendicular, or neither? All right, so the important part is to get the slope. So this one right here is in form of y = mx plus b, so I know its slope is 3/4, so I'm going to start with that one. I'm going to get y by itself here. There's a couple ways you can find the slope, but I'm going to do that. So I'm going to subtract the 4x over. Then I'm going to divide every single term by that -3. So when I divide this by a -3, I get two negatives make a positive. Divide 9 by a -3 gives me -3. So the slope is right here, and the slope of that one is 4/3. All right, so I'm looking at 3/4 and I'm looking at 4/3. And then I ask, are they the same? Nope. Are they opposite reciprocals? They are reciprocals, but they are not opposite. So the answer to this one is that they are neither parallel or perpendicular. They're just going to be, you know, maybe one would be a line like this and one might be a line like that where they intersect, but they're not parallel or hitting at 90-degree angles. All right, so this one I need to get y alone, so I'm going to divide everything by a 6. So I'm going to get y is equal to -1/6 x, and 6 divided by 6 here gives me a +1. Over here, y is already by itself, so I'm going to look here. Here's my slope of this one. Here's my slope of this one. And if you notice, they are the same, so these two lines are parallel. Okay, when you take a look at this, same thing. If you ever have an x equals and a y equals, we graph these. Remember, the x equals is a vertical line, a y equals is a horizontal line. Vertical and horizontal are always perpendicular. Okay, I'm not going to do that last one. Let's go over here and go through some more equations. Top of page 215, we're going to do something very similar to what we did earlier. It's going to go through this point, but it's perpendicular to that one. So I'm going to bring down the point we're going to use. And I know it's perpendicular to this. So since it's not parallel, I don't want to use 2, but I do want to use its opposite reciprocal. So if 2 is 2/1, that means the slope I want to use is 1/2, but since this is a positive, I need the negative. All right, so now I'm given a point in the slope, and again, once I use that, I can ignore that, and I'm going to go do the same thing we were doing before. So we're going to do y is equal to -1/2 x plus b. I'm going to put that in for that in for your x, so you get 8 equals -1/2 plus b. I'm going to add that half over to the 8. And I get that. So finished answer in slope-intercept form, which is what it's asking, is y equals -1/2 x plus 8.5. And that is the answer to that question. There's the equation that is perpendicular to this one that goes through that ordered pair. All right, so I come over here. Here's my point I'm going to use, 5, 0. Now, this equation we need to notice is in point slope form, all right? The point is 3, -1, but that's not important. What is really important is the 2. So again, I need it to be perpendicular, so I need to use its opposite reciprocal, which is still -1/2. Once I get that, I don't care about that equation anymore, all right? So I'm going to come over here, and I'm going to start it out again. Y equals -1/2 x plus b. I'm going to put 0 in place of the y. I'm going to put 5 in here, which is -2.5. Add your 2.5, so you get b to equal 2.5. So we're going to say y is equal to -1/2 x. I'm going to put 2.5 in place of that b. Okay, and there's my equation. All right, again, pause the video if you need to get to try this. All right, we have to get y by itself on here because it's in standard form. So getting y by itself, I need to subtract that x over. Then I divide every single term by a -2, and again, a negative divided by a negative is going to give me a +1/2. Remember, this is a 1x here, so when you divide by 2, it becomes 1/2. And then -2 goes into -4 twice. Again, I don't really care about this. We're not going to use it, so if you divide wrong back here, it doesn't matter. All right, what's important is that the slope right here is 1/2. Again, we're doing perpendicular, so I need its opposite reciprocal. Its opposite reciprocal would be a -2. So we are going to use -2. Now I don't worry about any of that. Using the point and the slope, I'm just going to jump right to it. So y, that's the y, equals m times x, because it's mx, so m times x is -2, plus b, add the 2 over to this, gives me -4 to be my b. So I have my b, I have my m, I put it all together, and say y equals, whoops, that should be a 2, sorry, m x plus b, and there we go. All right, okay, let's just go 216. I'm going to do one of these word problems here. So it says you have an urban planner. Urban planners make maps of cities, parks, things like that. So they're going to have a path for a new city park that will connect the park entrance to Main Street. The path should be perpendicular, there's a key word, to Main Street. What is the equation that represents the path? All right, so we need it to be perpendicular to Main Street. So the first thing I need to do is we know we're going to enter right here at the 4. All right, so that's the park entrance. So I know my y-intercept is 4. So I don't even need to solve for b because I know my b is going to be 4. All right, so I wrote over here b is 4. So basically it's going to come through here and it's going to hit this at a perpendicular line. So in order to do that, I need to find the slope of this. Well, you can find the slope of a graph by using 2 points along that line. So it looks like there's a point right here and right here. All right, so I get from there to there. We're going to do our slope triangle. So it looks like we rise 2 and run 1. So the slope of Main Street is 2/1. That's the slope of Main Street. But since we are doing one that's perpendicular, we need to use its opposite reciprocal, which is going to be a -1/2. All right, so we have everything we need. So we're going to write y equals mx plus b. There you go. There's the equation of that street. So hopefully that is clear enough on there. If you have any questions, just ask me. If you're still lost or confused, get on your Pearson account and watch those videos, or you can always YouTube a video about writing equations for perpendicular and parallel lines. Hope that helps. Bye.